Why air needs to be purified. The World Health Organization estimates that 4.6 million people die each year from causes directly attributable to air pollution. Presence of particulate matter in the atmosphere is a major cause of lung cancer, while addition of greenhouse gases such as nitrous oxide, methane, and CFCs is leading to increasing average temperature. Even though the best way to approach this problem is to eliminate its root cause, the generation of toxic and greenhouse gases, doing this has proven to be increasingly difficult. Toxic gases generated by industries can be treated and monitored to some extent. However, the leading cause of pollution and smog in countries like India is burning of stubble and farm residue. Pollution caused by burning rice husk, for instance, is very difficult to monitor. Moreover, in cities that are already polluted way beyond the ideal pollution level, the most effective way to address this problem would be to combine the monitoring and treatment of toxic gases in industries and to clean and purify the existing polluted air. An air purifying plant can be built in cities to suck in polluted air at great heights by creating a suction pressure and release fresh and unpolluted air back into the atmosphere to rid the air we breathe of pollutants and provide us with useful byproducts along the way. The air purifying plant is to contain different chambers, the first one being suction chamber, the second being separation chamber, the third being treatment chambers, which are further divided into gas treatment chambers and water treatment chambers, and the fourth being storage chambers. The primary function of the suction chamber is to create a very low air pressure area so that by creating a suction pressure, large volumes of aerosols in the atmosphere can be sucked in. In the separation chamber, the polluted air drawn in is most likely a mixture of the gases sulfur dioxide, nitrogen dioxide, etc., and the normal components of air being nitrogen, oxygen, and argon. The first step of gas separation is filtration, where dust particles and water vapor are removed. Next, by carrying out the process of cryogenic distillation, polluted air is separated into its components that are collected in the gas treatment chambers. After the separation of pollutants, fresh air is released back into the atmosphere through a chimney. The gas treatment chamber consists of various chambers where the collected gases are reacted with certain compounds to produce useful products. Sulfur dioxide is passed through water to give sulfurous acid, which is then oxidized to give sulfuric acid. Sulfuric acid is reacted with sodium hydroxide to finally result in sodium sulfate, which is also known as common salt. Nitrogen dioxide is reacted with water to form nitric acid and nitrogen monoxide. Nitrogen monoxide is passed on to storage chamber, while nitric acid is reacted with magnesium hydroxide to give magnesium nitrate. Carbon monoxide is oxidized to give carbon dioxide. This carbon dioxide and the one collected from distillation are together reacted with calcium hydroxide to give calcium carbonate. The carbon-fluorine bonds in CFCs are made to break, giving a compound with silicon-fluorine bond, which is no longer a greenhouse threat. With research support from the Department of Energy, Sloan Foundation, and Research Corporation, Ozerov identified a new catalytic process for a class of carborane sililium compounds that causes the bonds in representative HFCs to react at room temperature, swapping their carbon-fluorine bonds for carbon-hydrogen bonds. The sililium catalyst performs the critical task of breaking the carbon-fluorine bond by abstracting the fluoride from the fluorocarbon and attaching it to a silicon atom. The end product is a compound with a silicon-fluorine bond. In the water treatment chamber, depending on the amount of water vapor in the atmosphere in the city, it can be decided whether to release back all of the water vapor that had been drawn in or to hold back and release only some amount of it. If some of the sucked-in water vapor is held back because of there being excess water vapor in the atmosphere leading to greenhouse effect, then that water, along with the water released in all the previous gas treatment reactions, are filtered and made suitable for usage. This water can be reused to carry out the reactions in the gas treatment chambers. Storage chambers. In the storage chambers, the products created in the gas treatment chambers, such as sodium sulfate, magnesium nitrate, calcium carbonate, nitric oxide, and the byproducts of CFCs are stored. Some of the components of air after distillation are directly passed on to the storage facility, bypassing the treatment chambers. These include methane, nitrous oxide, HFCs, and PFCs. The uses of stored products. Sodium sulfate can be used as a filler in powdered form in home laundry detergents. It can be used in the glass industry. It can also be used in the manufacturing of textiles. Magnesium nitrate is mainly used as a fertilizer. Calcium carbonate can be used in industrial settings, as a fertilizer, or in the construction industry. Methane can be used as a very clean and efficient fuel. Nitrous oxide has medicinal use. Nitric oxide also has medicinal use. And HFCs are used in refrigeration, air conditioning, building insulation, and fire extinguishing systems. Air is sucked into the purifier by creating a vacuum pressure. The mixture is filtered to remove dust and water vapor. Filtered air is liquefied at -210 degrees Celsius. Through the fractional distillation column, different components of the polluted air are separated, and oxygen, nitrogen, and argon are passed on through the chimney back into the atmosphere.